Okay, we're going to work on topic number 9 right now. So what we see here is that we have common bases with exponents of fractions. Well, we know that if we have common bases, we're going to have to add our exponents. And honestly, this is something that I would just do on a calculator, but I don't even have a calculator right now, so we're just going to do this by hand here. So I see if I add my exponents, it's going to be nice on this problem because we have a 3 as the denominator on one side and a 9 on the other. So I could change this fraction to 6 over 9, which is the same thing as 2/3. And then it's easier for me to add those together. If I'm adding those fractions, that would be 10 over 9, and that would be my new exponent for x. So again, you could just do that on a calculator. 2/3 plus 4/9 is 10/9, and that's all you have to do for topic number 9. Topic number 10. Now we are dividing with common bases. That means we're going to subtract our exponents. And I'm going to grab a calculator quick. And what we're going to have to do here is we're going to have to subtract 1/2 minus 6/7. So 1/2 divided by, or I'm sorry, subtracting. We're subtracting exponents because we're dividing these common bases. So minus 6 over 7. That's negative 5/14. So it could be x to the negative 5/14 power, but that is not simplified all the way. I actually have to flip that to the bottom of the fraction and make it x to the 5/14 to have my final answer. So that's it for topic number 10. Topic number 11, you can do this a couple different ways. I'm going to first start by just combining the bottoms first. I'm going to add those exponents together. So we'll have 1/4 plus a negative 3/4, which is negative 1/2. I guess I could have figured that out without using a calculator. So that would be down there, and then we would have y to the 1/3 on top. And then what I need to do is I need to take the 1/3 minus the negative 1/2 because now it's subtraction. So 1/3 minus or plus, I guess, 1/2 because it's minus a negative, which is 5/6. Okay, that's the final answer. Topic number 12. We're doing power of a power now, which you shouldn't need a calculator for because we're going to be multiplying our exponents. So if I multiply those, that's like 3 over 1. When I multiply fractions, it's top times the top and bottom times the bottom, which means we have y to the 6th over 9, which is the same thing as y to the 2/3 power. Topic number 13, same situation here. It's power of a power. So if I multiply negative 5 times 1/4, because this 1/4 is going to have to go to both of those, we would get negative 5/4, and b would be 4 over 20. And then I'm going to have to rewrite this. I want the a on the bottom, so I can make that a positive exponent. And then b would just be the same thing as 1/5. So that's it for topic 13. Topic 14, I see I have the square root of 75. 75 is not a perfect square, so I can't square root that. But I know I can separate it into the square root of 25 and 3. I chose 25 because 25 is a perfect square. So the square root of 25 is 5. And that 3 is just going to have to hang out as a final answer. But again, the splitting up came from, I knew 25 times 3 was 75, and 25 is a perfect square. So you're going to have to find your perfect squares. Topic number 15, we've got 171. This is all of these numbers are going to be bigger than 100, so you might have to do some trial and error to see what works. Again, our perfect squares are 1, 4, I forgot 9, 16, 25, and so on. But I don't think we need to go up any higher than that because I think I know what this one is. I think 9 goes into 171. I just got to figure out how many times. 19 times. So I can split this up into a 9 and a 19. The square root of 9 is 3. The square root of 19 can just come down. 19 is a prime number, so that's going to be stuck there. But you could check to see, okay, does 4 go in? Does 9 go in? 1 obviously goes in, but that wouldn't really help us at all. So, yeah, we're done with that one. 3 times the square root of 19. Topic number 16, we've got a square root shown here. I'm going to have to separate this. I'm going to do it this way, kind of the long way here, but I know that I can separate it into the square root of 48, the square root of s to the 9th power. That's supposed to be a 9. Let me rewrite that. And then the square root of t to the 7th power. Okay, the square root of 48, I'm going to have to separate that. I know 16 is a perfect square that goes into 48, so I'll split it into 16 and 3, because 16 times 3 is 48. When I look at s to the 9th, I can't really do anything with that. If I think about s to the 9th as a square root, this is really the same thing as s to the 9 over 2. We've talked about replacing that or rearranging it so that it's an exponent. I can't really do 9 divided by 2. It'll give me a decimal. So instead, I'm going to change this to the square root of s to the 8th and the square root of s, which together, if I multiply those together, would be s to the 9th. I'm just taking 1 off, basically. And I'm going to do the same thing with the t. That'll be t to the 6th, and then just a regular t I meant to write. And now what I can do, if I do the 16, I'm going to have to go through my writing here. 16, the square root of 16 is 4. I'm going to save the 3 for just a second. I'll do this one next. The square root of s to the 8th is like 8 over 2. If you don't remember, there's really a hidden 2 on all of these for a square root. It just doesn't have to be shown. It's implied that it's there. So then if I rearrange this right here, that would be like 8 over 2, which is 4. So it would be s to the 4th. I'm going to do this one next because I know I can do it. T to the 6th over 6 over 2 would be 3, so it'll be t to the 3rd power. So I've done all of those so far. Then everything else I can't really do anything with. So I'm going to put them back under the radical. So that 3, the s, and the t that were left over that we kind of pulled out, those are going to have to stay there. But we were able to simplify part of it at least. So technically this is more simplified. Topic number 17. I'm trying to find a perfect cube that goes into 81 now. Now let's talk about our perfect cubes for a second. Since these get big really fast, I'm only going to do about 5 of them. 1 is obviously 1. But if I did 2, 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And I think we're already too big, so we'll just stick with those. If I look at 81, I think 27 goes into 81. So I'm going to split this up into the cubed root of 27, and it's 27 times 3. That gives us 81. So I got to make sure I put my cube root there again. But the third root of 27 is 3, and then the cubed root of 3 just has to hang out because we can't really do anything else with that. Topic number 18. I'm going to split this up again. So let's split it up into the third root of 54 and the third root of y to the 10th. The third root of 54, if I wanted to find a perfect cube that goes into 54, I think 27 goes in again. So I'm going to split that into the cubed root of 27 and the cubed root of 2. And then when I look at this, it's a little bit different than the last time we did these with variables up here, because now we have a cubed root. that means I need this number to be divisible by 3 to work. So I will choose y to the 9th power. Then I'll have 1y left over. I don't have to put y to the first, but I will for the sake of showing you what's going on here. And then let's just go through our next step. The third root of 27 is 3. The third root of 2 I can't do anything with. So I'm just circling the ones that I'm done with. I'm done with that one. I'm going to go over here to this one because I know I can do that. That's the third root of y to the 9th. That'd be 9 divided by 3 is 3, so it'll be y to the third. And then I just have these two left that I can't really do anything with, so I'll just put them back under the radical. Make sure you put the 3 as your index. 2 and y go back under. Topic number 19. So I can't add these together right now because I would need common numbers under my radicals. So what I'm going to do is I'm going to separate that radical 98, or the square root of 98, and try to simplify it a little bit. Then I'll simplify the 72 at the same time, and we'll see if we can get the same number under the radical. So the square root of 98, let's see. I think 49 goes into 98, so 49 and 2. And then I'm going to add on that 3 is there, 72. I think 36 goes in twice. So then the square root of 49 is 7. The square root of 2 will just hang out. Plus this 36, the square root of 36 is just 6. So 3 times 6 is 18 root 2. Now that we have the same thing under the radicals, we can add those together. 7 plus 18 is 25. And the root 2 will just stay there. This is the same thing as if I were to say, what is 7x plus 18x, right? You would tell me that it's 25x. That's why it's 25 root 2. Topic number 20. Looks like it's got some stuff separated for us already. I don't know if it's separated the way that we want it to be separated, but we have 19y to the 7th times the square root of y plus 2 times the square root of y to the 15th power. When I'm looking at this, I think we want to separate things, especially this y to the 15th power. That way we can maybe get the same thing under the radical again. So if I separate that, I'm going to separate it into y to the 14th and y. So then I'll have 19y to the 7th root y plus this is really the same thing as y to the 7th. So then I'll have 2y to the 7th root y. And now you can see that we've got the same thing on the backs of both of these terms, I guess. So we can add them together, which means we'll end up with 21y to the 7th root y as your final answer. Topic number 21. All right, so what can we do here? Let's see. We're multiplying these two radicals together. So basically what we could do is this. We can combine both of those things under the same radical. And that's a good call. Now we can go 12c to the 7th. And then we're just going to simplify this like we did in our previous questions. So I can separate this into the square root of 4 and the square root of 3 for that 12. And then the square root of c to the 6th and the square root of c. So then we would have, let's see, the square root of 4 is 2. We've dealt with that. The square root of c to the 6th is c to the 3rd. We've dealt with that. And then everything else will go under the radical. And we're finished. Topic number 22, we're going to rationalize the denominator. To do that, I'm going to, so basically, the gist of this is you can't finish a problem with a radical on the bottom of a fraction. That's just not mathematically finished yet. So what we're going to do is I'm going to multiply this by 1, except, and so I'm going to multiply by 1 so I don't actually change the number, but my number 1 is going to look a little bit different. So, I mean, I think you can agree that that's actually multiplying the fraction by 1. But what's going to happen here is we'll have root 5 times root 7, which is the square root of 35. And then under it, the square root of 7 times the square root of 7 is just regular 7. And looking at this problem, I don't think there's a perfect square that goes into 35. So that would mean we're done. We don't have a radical on the bottom anymore. They would consider that complete.